Hello everyone. Today we are going to take a look on question number 5, first part of exercise 8.4. So basically the question says cosec a minus cot a whole squared should be equal to 1 minus cos a upon 1 plus cos a. So we just need to prove that when we expand this and whatever we do with this should all be equal to, basically the value should come out to be this. Okay. Then firstly we have to see to the RHS, and we see that RHS is already in the terms of cos and sine, and when and these are the simplest forms. They cannot be converted into any other degree. No, they can be converted into like 1 by cosecant and 1 by secant, but they are not the main identities. Sine and cos are the main identities. If it was in tan, we might or might not convert it, but let's see it right now. Firstly, we will write LHS and RHS as usual. Put a line in between, dividing the border. Then we have to write the same question LHS here and the RHS here. We just need to write it for like sake of a reference, and it has to be written every time. You cannot skip it. This is a necessary step. So let's begin with the LHS. Uh, we can see that we can apply an identity known as a squared minus b squared. Basically, I mean a minus b whole squared, right? So let's start. Cosec whole squared. So we know minus 2ab. So cosec a cot a, and 2, yes, 2 we can adjust this side, not an issue. Then we have cot a plus cot squared a, right? So now obviously it's not equal to that. Then what can we do? Simplest thing we can do is convert them to the main degrees. We know cosec is the opposite of sine, so basically 1 by sine square a, right? And we will need to solve this. Then we can write 2 multiplied by cosec is again 1 by sine, and cot is one special degree. Then see, it's really simple, cot a. Okay, then we have, what is cot a? We know cot is reciprocal of tan. Yes, and we know tan a is equal to sine and cos. Sine, like in terms of sine and cos, sine upon cos a, right? So implementing this into this, it would be basically, is equal to 1 sine 1 upon sine upon cos a and a, right? Nothing much. Then we know we just invert this. This is up, so this will be down. This is down, this will be up. When we bring it to the upper hand, like the topmost one, uh, cos a upon sine a. So this is the value of cot a. So we can directly use this identity. There is no use of like showing it here because no one would see that, and it would just waste our time and space. So just directly write it. Okay. Then we know cot a. So yes, cot a is again. So basically it's cot a squared. So square basically means I write cos upon sine, then a in front of them, a. So I won't write squared here. I would write it here, right? So is that's basically sorted. And now we can see, let's just simplify it first. The simplification is the most important thing in trigonometry, and that has to be done every time. Okay, let's continue. No stopping, because 2 cos a we know, then that is already simplify. Sine squared a, right? This question is pretty easy. Now, see, it's pretty easy because we see sine squared in all the denominators. Now we'll just solve it. 1 minus 2 cos a plus cos squared a. And if it is like this, you can even solve this. It's don't need that you need to bring that cos squared a in the front and one to the back. That's like not needed. That's not always needed, no? So yeah, sine square a. Now you'll think, what can we do of this? So I think everyone can see a pattern here. This is 1. You can write it on 1 square, right? It's the same thing, 1 as 1 squared. Then we have to leave this. Let's see this. So cos squared. So I see a squared and I see b squared. And I also see if we multiply them both with 2, it's minus 2ab. So it's basically plus, right? So 1 minus cos, that is b, a, a is 1, whole squared, right? And sine squared. You must be wondering what would be sine squared. It's a really confusing concept. No, it's pretty easy. Sine square a plus cos square a is equal to 1, right? We know this. This is the identity. Then sine squared a is equal to 1 minus cos squared a, right? So we have the value of sine square a as 1 minus cos square a, right? So now you must be wondering, what can we really do? No, we can do everything now. Now basically last step is left. So once, like 1 we can write, I told you 1 squared, we can write it at any power, it says 1. So we can modify it accordingly. So this is squared, and we know something is known as a square minus b square, which is equal to a minus b multiplied by a plus b. This is multiplication, not division, okay? Then next step, 1 minus cos a whole squared. Wait a minute. 1 plus cos a. So we can write it in any order. It's not necessary that a minus b has to be first. Doesn't really matter. 1 cos a. 1 minus cos a. Now we see this is in multiplication. This is whole squared, like 1 minus cos a, 1 minus cos a. Instead of writing it like this, we can write it as cos a, right? So this is the same thing as writing as a whole square. Then we see that this identity and this identity is the same, so they can be cancelled. They are now out of the equation, and let's just write the result what we are getting and see if we can really simplify further. 1 minus 1 plus cos I. I think that should be the final answer, but I know a lot of you must be thinking, why just leave the answer like this? Just because it is equal to RHS. We can't we just, rationalize it? Just see, if we rationalize it with 1 minus cos A, so it would bring the same result as 1 minus cos A multiplied to this, would be this, right? And we would get 1 squared minus cos squared A, and to this it would be 1 minus cos A whole squared. Are you understanding? So basically we are reversing a step. That's not a thing that we should do really, because it's increasing our work. So we can, I think this is the LHS, right? Yes. If this is the LHS we get, and this is now the RHS. Do they match? Let's just check. I think if you want you can, and yes, LHS. So last line we write LHS is equal to R oh, RHS, hence proved. This line is also very important, I can say. The like if you can write so if you want, and then write therefore, this is very important. Or instead of writing therefore, you can write hence proved. This is much better, I can say that, right? Hence proved looks much better. Hence proved cosec cosec a minus what was it? Yes, do you remember? Yes, cot a whole squared should be equal to 1 minus cos a upon 1 plus cos a, right? So everybody, thank you for watching this, and I hope you understand the concept. And this core topic cannot be learned, it has to be kind of memorized. That what should we do, it should instantly hit your mind that which step should be next and what should I do, because every strong step wastes your time, which is very precious during exams, no? So thank you for watching, and meet you in the next video. Bye bye.